సో ఒకసారి లింక్ ఓపెన్ చేయగానే యూజర్ ఐడి పాస్వర్డ్ రిజిస్టర్ అయ్యారు కదా, నీట్ సైన్. So the other day we tried to download. Yeah, కిందకి వెళ్తే the down. But what I need to download is this one. IBM Netezza client components version 7.2 for Windows.
Yeah, Abhi, my agility is up. If you want, I can share.
So if I just continue, what this product will bring in is this product will bring in
రవి మీ స్క్రీన్ క్లియర్ అవ్వట్లేదు అవి. This is for drivers, right?
Yeah, this will get IBM Netezza Administrator Client Tool. Let me make you the presenter. You are ready?
Yeah. Oh, you're asking Srinivas ready or me, Ravi?
Yes, Srini, one second. I'm making the presenter. Yeah, before we go there, Srini, can you please open the link I've just given you?
Sure. Yeah, it's ready. Oh, I think I need to select my complete screen.
Okay, yeah.
Okay. Let me know when you're ready.
Okay.
Yeah, just open that link.
Yeah, you remember your user ID password that you used?
No,
Oh, that's okay. So this is the link you need to open, Srinivasa.
Okay.
Right, same link used to download 7.2.
Emulator. Okay.
yeah, it's working, Ravi.
Yeah, okay. Look at that. Scroll down, fifth one, I think, on top. Yeah,
Windows 7.
Windows. Yeah, for Windows 7. That's the components we need to download. Yes, Pro. Yeah, it's the component you need to download. What it brings in is it brings in one zip file.
Okay.
Once you extract the zip file, you'll get 3 directories. The first important directory is document. So it has all the documentation, official documentation from IBM. The second important directory you get is drivers.
Okay.
You get ODVC drivers, JDVC drivers, OLEDV drivers. If you look at Agility, Agility is a front-end client from a company called Agility, not from IBM. So you need some kind of mediator, right? That driver, which helps you communicate between these Agility to Netezza. So first you need to install that Netezza ODBC driver. ng ODBC setup.exe will be there. And third important directory is admin. Admin has one Netezza admin tool called IBM Netezza Administrator. So first download it and I can walk you through that process.
Okay. Sure.
In the meantime, this is how the agility workbench looks like. If you can open it from scratch again, Srinivas,
Yeah, sure.
just please close that.
This
Yeah,
So do I need to close this and reopen it?
that's okay. That's okay. Otherwise, because
Okay.
what we're doing here is, just like a plain straightforward installation. Hold on, let me see if I can, if I am ready here. Right. So there can you on the left side. It's like, do you have experience with a SQL developer or a Toad, Srinivas?
Yeah. Ravi.
Same.
Yeah, Ravi.
On the left side, you have databases. If you expand any of the table, just right click on the table. Yeah, go to table section.
Okay.
Yeah, right click on a table. So, right click. Go to script.
Okay.
DDL to uh, DDL statement. DDL to clipboard. Or DDL to query window. Yeah, it will just get you.
So, Ravi, all slash commands are designed for only NZSQL, right?
They are only for NGSQL, right?
Okay.
They don't work outside.
Got it.
Okay. Any other questions, really? Srinivas?
Uh, no, Ravi. Actually, I practiced yesterday. It looks. I mean, I'm good with it.
Okay, let me take control now. And
Sure.
the last thing I remember we discussed was about tables, right? Databases, schemas, and tables. And Srinivas, you were yesterday mentioning about an issue when you're trying to do set catalog.
No, no, now I'm able to do, Ravi. No issues.
You able to do it.
Yesterday I was forgot to specify, semicolon end of the command. Due to that, I was facing.
This is how it looks like. What I've just done here was I typed after installation agility workbench. It shows an interface like this. So just click it on. So it opens something like this, and I just say close this. Then it pops up the connection information, some name, so that I can remember this. So what is my IP address? What is my user ID? What is the password? Here the user ID and password are database user ID and password. The database which I'm connecting, at what port number. So this drop down must have a value, otherwise you cannot click on OK. So how you get the value for this drop down? Very easy. After you download the Netezza Windows client, go to drivers and install any one of the driver. Right. So prefer
Okay.
ODBC driver. Then it will automatically pop up. Click on OK. It will go in. That's when you see the interface. So that's really okay. All right. Let's get good. One quick second. One quick second. Just one second. All right. If I do a quick recap, in the last session, what we looked at was how do we create a database, create database option, create schema, and schema by default you cannot have multiple schemas created, and the important changes came from 7.0.3 onwards. Then we looked at create table. Now what we'll be looking at here is what are the various data types we have. So how do we create various other objects? So let's first look at what are all the various Netezza data types. Netezza supports 6 different data types. The first one is exact numeric data type. Right. When I say exact numeric, it exactly holds the value. So it's not like it stores approximations. It's not like floating or real values. It exactly supports. So the equivalent in other database environments is like number without any precision. Right. So there are two types again here. One is integer, another one is fixed point numeric. So under integer, I have four types of such data types: byte int, small int, integer, and big int. Under fixed point numeric, I have numeric and decimal. Right. In Oracle, what happens when I don't specify any precision or a precision for a number? By default, it's 18 comma 0, right? So here by default it is integer. So the important point here is how much space they occupy. 1, 2 or 4 or 8. How much space they occupy. Right. So here when you look at, when you give precision of 9 or less for a numeric, it will occupy 4 bytes. Any precision between 10 to 18, it gives 8 bytes. From 19 to 38, it gives 16 bytes. Like it happens with number in Oracle, here also it takes 18, 0 by default. It occupies 8 bytes. This is very important for us to understand data types, Netezza, from performance tuning aspect. Why? If I ask this basic question to you, Srinivasa, I would like to store a person's age. I would like to store a person's age as an integer. Let's say I'm running an insurance company. I'm an insurance provider. I would like to store details of my customers. In this, one important characteristic of a customer is age, right? So I want to store age of a customer. Can you tell me out of these four, which is the best data type I can use for that column and why?
We can,
And here is a range. When I use into 1, these are
yeah,
the ranges I can use. Into 2, this is the range I can use. So what is your answer, Srinivas?
we go for integer version.
Okay, we can go for integer, right?
Hmm.
When I say integer, it means int or int 4. That means it occupies 4 bytes.
For
If you look at it, it has a capacity to store range between this minus number to this positive number. So why cannot I use small int? Can I use small int in place of an integer?
not sure.
Okay. So what we are looking at here is we are looking at here store customer age. So customer age can be something between 0 to maybe I can say 100, right? Do you know any person who lives more than 100 and claims for insurance? Or maybe, you know, 150 or 200, it's not more than that, right? Then this small int will suffice because it is storing from minus 32768 to 32767, right? Or
Yeah.
I can take a little chance here and go for byte int, assuming that no customer lives more than 127 years, right? So the point I'm trying to make here is when there is a chance to use lower data types, don't go for bigger ones because they waste space for you. They waste space for you. So here instead of integer, I can simply use byte int. So what are the advantages of using that one? Instead of me doing 4 bytes, I'm using only 1 byte. So if I go for integer, it occupies 4 bytes. If I go for byte int, it takes only 1 byte. So what we are looking at here is when I talk about a customer table, I have a customer ID, customer name, customer gender, customer age, etc. So let's say these are 4 columns. If I declare customer ID as integer, customer name as character of 10, customer gender as character of 1, customer age as integer. Integer occupies 4 bytes, this is 10 bytes, this is 1 byte, and this is again 4 bytes. The total row size is 18, 19 bytes, right? Instead of that, What if I declare customer age as byte int? My row size will reduce to 16 bytes. Here we are talking about just one row reducing 3 bytes. What if my customer table is like 500 million records? Right. So that brings me to the day one. Let me open this presentation. You remember, right, what FPGA does for us? What
Yeah.
FPGA does? It filters out unnecessary columns. Look at this. FPGA helps us to reduce unnecessary columns or unnecessary rows, right? So
Yeah.
you might still need customer A's, but customer A's, it cannot reduce the data type length because it does not have that capacity, right? If you don't first of all need customer A's, why do you have to transfer it from this storage location to this location, right? Let's say you are transferring it instead of 1 byte. If you are transferring 4 bytes for 500 million records, how much is the wastage you are transferring, right? So that's why these plays a crucial role. If you look at Netezza, by the end of the classes you understand the performance tuning is very easy because majority you don't have to do it. System does it automatically. There are few places where you need to put some effort on. The first one is when you declare these data types. If you look at these Netezza projects, majority of them are migration projects. So say you have Oracle warehouse, you want to migrate it to Netezza. Say you have a DB2 mainframe warehouse, you would like to migrate it to Netezza. So when you do such kind of a migration, you tend to have an equal data types that used in legacy data warehouses. So that's where, as an architect or as a developer or a DBA, you need to spend some time in understanding what is the data type I can use it. So there I'm using like number 18 comma 0 or A's. So can't I just use integer or can't I just use small int or a byte int? At least every byte you save here at a design will help a lot down the line. Did I make sense on this? Okay. The second data types we have is approximate numeric data types like float, real. Do not use floating point data types for distribution columns, join columns, or for columns that require mathematical operations such as sum and average. Why? Because Netezza cannot run a fast hash join on a floating point data type, but instead it must run a slower sort and merge join. If you have involved in any tuning before, if you look at or if you analyze this explain plans, right? Say that explain plan for select customer ID, customer name from customer table where customer ID equal to 500, right? This is how you generate explain plan, right? You say select star from table image underscore explain dot display. This is what you say, right? In Oracle. What it does, it will generate an explain plan and when you look out for things in that explain plan, right? Right. So the few major things we look at is how this customer table is getting accessed. Is it doing full table scan or is it doing an index scan, right? Let's say when you are joining customer with orders, Let's say when you're joining customer with orders, right? So how both tables are getting joined? How both tables are getting joined, right? So when I say join, there are three ways, three major ways where both two tables can be joined. One is using hash join, another one is using nested loop join, the third one is sort join. Hash join is the fastest because it happens in memory. Nested loop join is the next fastest. The syntax here is very easy, two for loops. For every record in the outer loop, that is for every record in the customer table, you go and scan all the records in the orders table, right? So then merge sort join is it first sorts the data, then as a merge join, right? Merge sort join is the slowest one, right? What happens here is when you have your join column, let's say customer ID is declared as integer, it might go for hash join. When you have this customer ID declared as float, you will definitely go for merge sort join. So that's why it's not encourageable to use most important join columns as non-integers or non-date. That's what we are trying to show you here. Even that's the same case in Netezza. When you declare any such columns as a floating point or a real, where they have a capacity to store approximate data. Where they have a capacity to store approximate data, instead of we going for a fast hash join, we are going for merge join. So try to avoid them floating or real in the distributions. Now, anyway, we'll talk about these distributions, but if I show you that what do I mean by distributions, let me plug in here. Well, let's say I create a table called test 10, column 1 integer, column name character of 10, is character of 20. When I create a table like this and when I describe it using \d test 10, this is like a DSC describe command in Oracle. It will show us the table description, right? Number of columns it has. And the important thing here is it shows distributed hash column 1. It shows distributed on hash column 1. So we'll talk more on this in the next class. But for now, this is like a partitioning key, right? This is like a partitioning key. So what we are trying to show here is don't have these distribution keys on non-integers or non-dates. So when I let's say declared customer 1 as a floating point, for example here I have test 11 column 1 float. So if you don't specify any distribution column, by default it's a hash distribution on first column. So these all looks like exactly same, these two definitions, test number 10 and test number 11, both tables. But when you work in a real time when you are trying to join this table against C1 with some other column, you will get a nightmare performance. Why? Because your C1 is the most important column and it is a double precision. So it always goes for merge joins because it stores approximate data. So first it has to sort the data, then only it can work on it. So try to avoid having those columns as distribution columns. And the third important one, of course, is the character data. We store char or a varchar, right? So the maximum you can store in a char or a varchar is 64,000, which are followed by national characters, nchar and nvarchar. Just in case if you want to store non-English characters, right? If you look at English character, each English character needs 1 byte. Some languages such as Hebrew or Chinese languages need 2 bytes for their one character. So such characters you can store it in nchar or nvarchar. The fourth data type we have is a Boolean. As the name says, it takes only two values, either true or false, on or off, yes or no. The fifth data type category we have is temporal. As the name says, it's temporary. Okay. Temporary in the sense, if I ask you a question that what is the time right now, you say like, okay, time right now is. To answer the same question an hour later, you say that, okay, time right now is. It's the same question but gets you the different data, right? An hour difference data. Now what exactly changed there? Same question. Nothing changed except the time. So that's why we call them as a temporal. The changes with time. Date, time, timestamp, time with zone, and interval data types. And the final data types we have is a binary data type. In other environments we have like blob, glob, byte, right? To store binary objects, to store large character objects, to store log files, large objects as attachments. We have various data types. Netezza supports only one such data type called var binary. Whether you are talking about a binary data, you are talking about a character data, you are talking about an attachment, big file, you simply have only one thing called var binary. That's it. And please note that it supports only till 64K. You are not literally talking about huge file storing here. st underscore geometry. This is used generally in research, that kind of environments where you have to store three-dimensional information, three-dimensional figures, Google Maps and that kind of an information can be stored in this. In summary, what we are looking at is we are looking at 6 major data types. What are they? Fixed point, floating. If I quickly make a note here. Fixed point, floating, then character, Boolean, temporal, binary. All this information you can find it in a table called underscore v underscore data type. When you run a query called select start from underscore v underscore data type, you get that information here. Okay. Any questions so far?
So, Ravi, so in case if the like for example, 8 GB and all that we can capture right in Oracle, but large objects are very large objects.
Right.
How to deal those kind of things in Netezza? I mean,
You have to literally split that files into small files that can fit it in 64, and you have to store them. There is no other option.
okay,
Generally, that kind of an objects appear in OLTP more because so when you ship something to the customer, like you might have to store the invoice, all that attachments, but such kind of a stuff generally don't store in a data warehouse. But just in case you still have to store a huge file, some environments it's much needed. You have to explicitly split the file and store it. No other option. Into multiple columns, basically.
okay. Yeah, but now most of the times that in our project like what we get is that comments, like user comments or something, sometimes people write like very big, I mean, at least a lot of lines they write. Yeah,
Yeah, but this can be considered as one of the drawback. However, yeah, it is arguments that very, very, I mean, literally no chance to store such a huge files in warehouse because warehouse is all processed data, right? Or put all those files in some temporary locations or common location and just give the only store the path in one of the columns. So, but 64K is the maximum you can get combined, not more. Along with these visible data types, Netezza has some invisible data types. What do I mean by invisible? So when I say select star from test 10, right? So when I describe these test 10, each column that is coming here, column 1, customer name, customer age, has a data type associated, right? But along with these three, there is something called row ID, data slice ID, create XID, delete XID, comma start from test 10. So these four columns I just described here are invisible columns. These invisible columns has their own data types, right? And the objective of this row ID is to store memory address where your actual row starts. Data slice ID is in which disk out of the 96 disks available on the top or n number of disks available on the top my row went. Create XID is a transaction ID that inserted it. Delete XID is a transaction ID that deleted that row. That means you have a capacitor to store the history as well. Now let me insert a record here. When I say insert into test 11 values, I say 501 Ravi age, let's say this thing. When I say insert into test 10 values, now when I say select, along with populating these three columns data, it also populated data for these extra four columns. Row ID, data slice ID, create xid, delete xid is 0. That means the row number 501 Ravi 20 started here on this memory address, which is went to a data slice ID called 2. How you know how many data slices you have? You can exit from here, or you can say backslash exclamation and GDS to run any OS level command equivalent to exclamation in other environments such as Oracle. You have two disks here, disk 1 and disk 2. So currently this guy went into disk 2. Why this guy went to disk 2 instead of disk 1? That concept we'll talk in Netezza distributions class. 38274 is a transaction that created this record, right? So however, when I say delete from test 10 where C1 equal to 501, if I run that BigQuery again, I don't see any data. When I looked at this concept called delete xid, I thought that whenever I delete a record, I should see the deleted record with delete xid non-zero. But instead of that, it's not showing that row at all. Then what is the concept of delete xid? When I set a flag called set show underscore deleted underscore records equal to true, when I run that again, that's when I see the deleted record. The deleted records are not visible to the standard queries by default. To make deleted queries visible, you have to explicitly set this flag. Then only you can see the deleted record. So in summary about the deleted records, what I am talking about here is deletes in Netezza are soft deletes. They are, imagine a concept called recycle bin in Windows. So similar concept, just in case if you by mistake delete few rows, you can get them back from this concept. How do you clean up these deleted records once you don't know, once you no longer need it? Is a different concept that we'll talk about in miscellaneous sections called broom table. But for now, our objective is to understand these extra four columns: row ID,
So,
data slice ID, create X ID, and delete X ID. Go ahead, Srini.
so how many records it can store, David, and where does it get stored? So, like, is there any limit to that? Uh, you know, say for example, especially uh, may not be data warehouse, but at least the project that I'm working, maybe in the operational data store, sometimes like it, we also delete and insert a new record, right? So sometimes even a million records we delete. So just for curious to know like how many records that it can store and where it gets stored.
Okay, right. So for that, we need to start looking at the basic storage allocation, right? So what are we talking about here? If I talk about a twin fin here, we discussed from day one that twin fin has 96 disks. Let's say this is a disk 1, disk 2, disk 3, disk 4. Let's assume only 4 disks for now. So each disk is 1 terabyte. But out of it, what did we realize is only 333 GB is the actual user data. Right. Now, when I create this table called create table test 10, What is the row size here? Column 1 is integer, which is 4 bytes. Column 2 is character of 10, which is 10 bytes. Column 3 is byte int, which is 1 byte. So what is the row size? 15 bytes. Whenever I insert one record into test10, it needs 15 bytes. Not just this 15 bytes it needs extra. What is that extra? It also has to store row ID, create XID, delete XID. Data slice ID is not stored here in the disks on the top. So row ID is again 8 bytes, create XID 8 bytes, delete XID 8 bytes. So along with this there is some other variable variants like 1 or 2 bytes. I'm not talking on it right now. So we are looking at approximately 24 bytes. Now this 24 bytes plus 15 bytes is approximately 40 bytes, right? So to store one record here, you need 40 bytes. Okay. Now when I, let's say, issue a command called insert into test10 values 501 Ravi, so let's say 30. When I insert some data into test10 like this, where this record will go and insert out of these 4 disks, right? That you don't have a control. So that depends upon type of distribution, whether you go for random distribution or hash joint distribution. Let me assume that it went into disk 1. Let's assume record is going to disk 1. Now out of this 333 available, right? Netezza system first checks, do I have any space already given for test10 in this disk 1? Already. If no, it will give you an extent. In D1 here, it will allocate an extent. An extent is a 3 MB size. Out of this 3 MB size, it divides this extent further into blocks. And the concept here is page. This 3 MB is divided into 24 128 KB pages. That means you will get one page allocated. What is one page size? 128 KB. So in this 128 KB, you will start storing these values. Plus this row ID, create XID, delete XID. So approximately you try to use 40 bytes out of 128 KB. How many bytes is 128 KB? 128 multiplied by 1024. These many bytes. 128 KB is nothing but 131072. So when you divide that by 40, approximately you can store 3276 rows. Once you consume this space entirely in a disk 1, if you still need some other space, it will get and allocate for you that another page, second page. Right? You see what we are saying? So like this disk 1, disk 2, it's up to you. First record can go here. Second record again can go here. Disk 2. third record can go to disk 1, fourth record can go to disk 4. So how that happens, we'll talk about in a distribution class, preferably day after tomorrow, right? But the allocation at a memory level happens in the form of an extent or a page. Please note that the extent is within a disk. An extent cannot span between disk 1 and disk 2. No, it is within the disk, right? Let's say if you are running low on the memory, low on the space here, you have no other option other than purging some data. Right. This is the same row size concept I'm talking about here. Along with these basic columns, you also have an overhead have create, delete, row ID. Please note that data slice ID is not stored here. The data slice ID information is stored on host disks. What are those host disks? When I run df-k, these are all the host disks. They are stored with here under ng data slice ID. So that host has better control on storage layout. So that host has better control on where the data is stored. So you have some kind of null vector and record length. For example, if you have any nullable column, stores information here. If you have any varchar columns, it stores information here. I mean, this is not something that you need to worry too much, like in traditional systems, because here space is fixed and you bought an enormous space systems. So it's not like, a DBA requires a developer saying that when you load huge data, let me know in advance. No, nothing like that is needed. That's about data types. Any questions on the data types? Okay. Now let's look at the next object, synonym. So few environments calls it as an alias, nickname, whatever the way you call it as. A short way of referring long names, right? For example, I am connecting to testdb1. I've been frequently accessing select star from system.admin.testn. I am little lazy about typing this big data. This big line. So I simply create synonym SAT10 for this guy. So next moment onwards, I simply say this short name. But the important point here is, how do you refer remote database objects? How do you refer objects, first of all? So you say object using simply object name. When I say select star from test10, it first looks for test10 object within the same schema you are running. This is a schema, which is as equivalent as running a command called select star from schema name dot object name, which is also as equivalent as running database name dot schema name dot object name. The point here is, an object can always be given in the form of three-part name. Three parts in this name. The first one is a database name, the next one is a schema name, The next one is a object name. Sometimes what people do here is simply say select star from testdb1, and they can ignore the schema name and just give the object name. The schema name will be replaced with the default username. What is the default username? Whoever created the database, admin most of the time. Right. If I want to, generally we use this syntax when we are using objects or referring objects which sit outside my current database. Like here, sitting in testdb1, you are trying to connect to different database. You don't need a you don't need a DB link to communicate between different databases because they sit in the same instance. Right. So what further we have is how do you display the synonyms using \d command. How do you order a synonym? How do you drop a synonym? The basic syntaxes. Okay. The next object we have is a view. Again, there is no difference with respect to view between Netezza or other databases. View is still used for two major purposes. One is to reduce commonly written SQL. The second one is security. No difference. Please note that view is not for performance improvement. View never provides performance improvement. View just simplifies the amount of SQL you write. What do I mean by simplification? Right. So when let's say if let's say I'm running the same query many number of times, right? Not just me, many number of users. So I can simply say create view v underscore id as select specific query. From next moment onwards, I simply say select star from v underscore id. That is one major use for view. View helps me to hide the big SQL. This line can be like 1000, 2000 lines. So it helps me to hide and helps me to reduce the amount of SQL we write. Simply select star from v underscore id. Done. And the second important usage is security, right? So what do I mean by security is if tomorrow one of you is coming and requesting me an access to this test and table. So, if I give an access to test and table, you will see all these columns information. However, you only need customer ID and customer name information. You don't need to know the customer age, right? But if I give access to entire test and you will see all the data. Now, how do I restrict it? I simply say create view v underscore test 10 as select only. So that instead of me granting access to test 10 table, I just grant select on v underscore test 10 to streaming. So we will learn about this grant command in next session. The important point I'm trying to make here is view is used for two purposes, which is nothing that Netezza invented. Same old view concept. View. The first purpose is reduce commonly written SQL. Second, security by not showing important columns. Does view improves the performance? No. Why? When you say here select start from test v underscore test 1, when you still say that select start from v underscore test 10, it will still go and get the data from base table only, right? To filtration for FPGA, it still has to pass entire row. You still have to pass entire row from storage layer to FPGA layer. Okay, so it no way reduces or helps us reduce the query response time. Just simplifies the stuff. So what if performance is a major criteria for me? Is there any way that improves my performance? That's where we go for materialized view. Right. You might heard this word called MV or a materialized view in other environments. But here is a basic business reason for it. I have a customer table which has customer ID, customer name, customer gender, customer address, customer phone, customer fax details, customer email, right? Now customer ID, let's say integer, character of 10, character of 1, 100, customer phone is character of 20, character of 20. So how much is the size? 4 plus 10, 1, 100, 20, 20, 200. What is the size of a row I'm looking at here? To store one record in this customer table, I need 4 plus 10 plus 115, 115, 135, 175 bytes. When I say 175 bytes, if I go back to the same FPGA diagram, still I need to transfer the same 175 bytes from here to here. Whenever someone requesting any of this column information, let's say if I'm just saying that select only customer gender from customer, even though I just need 1 byte, I still have to transfer all 175 bytes from here to here. That's when FPGA filters unnecessary columns such as customer ID, customer name, customer address, right? It's a good thing that FPGA is helping me filter. But first of all, why do I have to transfer the data? Can't I reduce the data transfer, right? It's a very important thing, very, very important concept. So FPGA is filtering the data once it moved from storage layer. Can't I first of all avoid doing the unnecessary data transfer? So when I need customer gender, why I'm transferring all the other data, right? Right. So what if I frequently select customer ID and customer name? Only these 14 bytes. Why do I have to transfer extra 161 bytes, right? So that's when there is a concept called MV came in picture, saying that create a materialized view MV underscore MV1 underscore customer, let's say like this, select only customer ID, customer name from customer table. What this guy maintains here is, this is maintained as a separate table. Even though name is little confusing, like view, this is not a view, this is a materialized view. Materialized as in it's physically gets stored. So this gets stored here as customer ID, customer name. So whenever I start inserting a data here, for example 501 Ravi, mail, India, customer phone number, customer email. The moment a row getting inserted into a main table, the same row gets inserted here too. That's the first difference you find with Oracle. In Oracle, you have an option to create materialized views with a refresh option later. But here there is no concept of refresh. It's always on commit refresh. If you remember in Oracle, you have something called on commit refresh. That means whenever you
It's
insert
not.
base table, it gets inserted in a MB table as well. Go ahead, Srini.
No, I said like in Oracle I did not find this option. Basically, we do a timely refresh, materialized. Yeah.
Right. However, there is also an option called on commit refresh. Whenever you have something inserted into base table, do you want that to be inserted in MV table as well? But we don't go for on commit refresh because it's a performance intensive. Because the commit get affected, because commit gets only response back when it commits in all its childs. But here there is no such option. It is a default one. You don't have any other choice to. The MV concept in Netezza is little different. It's not like a timely refresh or like complete or a full refresh later. No, I mean fast refresh. Whenever you insert some data in a base table, it gets inserted in MV tables as well. There is no concept of refresh from data point here. If you insert a record called 401, the same record is inserted here. Right. So if let's say someone is trying to select only customer ID, customer name from customer table. So now Netezza at a runtime transforms this query into this one. It rewrites the query. You don't have to specify MV here. System will choose the best MV for you. You just have to specify the customer table. it automatically picks the right MV for you. Right.
So Ravi, you mean to say with this on commit refresh, uh, it is a default option, right, in Netezza?
Right.
And especially when we deal with huge data volumes, I mean, just wanted to check with you, like, did you see any performance issues, or it's pretty fast?
It's a very fast because of its AMPP architecture where you
Mhm.
have multiple. Because these data loads happens over ETL, right?
Yeah.
So you don't have anything else running at the time. No simultaneous logs, nothing else. So these are pretty fast. Now these MVs are called as SPM views, sorted, projected, and materialized. You have also an option to have order by class, right? But please also note that order by is an optional class. What happens when I specify here order by is, right? Let's say this is how I have my data. Right. So the data comes here like this. What if now I created one more MV? Right. This time if I say order by customer ID. So data gets stored in ordered fashion here. The important catch here is once my MV gets created, if my original table has data in unordered fashion, the data will also come in unordered fashion. Even though my original definition has stored the data in order by. So the refresh here in Netezza terminology is sorting this data. When I refresh MV here, refresh MV2 underscore customer, it's as equivalent as sorting the data, nothing else. Right? Please also note that
So,
you cannot have more than one table in the from clause here. You have to look at it as a positive aspect because generally you create MVs by joining multiple tables so that at runtime you don't have to worry so much about the performance. But here Netezza says that you don't worry about performance, just make sure you select what are the columns you want. I'll join at runtime to give you the fastest result. So here are the few restrictions. Also you cannot have a where class here, there is no need. Whatever you specify in a base table, it also has to get reflected in MV tables. You can specify only one base table, no where class, no expressions, only user tables are allowed. That means whenever you insert something in a base table, the same thing comes to MV tables as well, because there is no where clause. Go ahead, Srini. You're asking something.
So when we create a materialized wave, even without specifying the order by, but later if we just do a refresh MV, then it automatically gonna sort it based on the. It automatically gonna sort it, or it's just gonna be as it is.
Oh, it's going to be in the same order as your physical table.
Okay.
So this is how you refresh an MV. Alter view, MV name, materialize, refresh. Here is a clear materialized view syntax. Right. Sometimes what happens is we might have like hundreds of MVs. It's sometimes not possible to go and refresh each and every MV. So is there any way, system level way, where we can simply say like refresh my all MVs? So there is a threshold called materialized threshold, which talks about how much is unorderedness in my how much unordered data I have, how much unordered data we have. One second. If you look at here, out of the 4 rows, I have 1 row unordered. That means 25% of data unordered. So this threshold specifies some number. The default number is 20, right? So but we can have an option to specify from 1 to 99, right? So when you have this number specified and when you just run alter views on materialized refresh, any MV which has unsorted data of 20% or above will automatically qualify and gets refreshed. So in summary, how many MVs I can create on on a table? There is no limit, but Netezza recommends to restrict that number to 4 to 5, not more than that, right? Because it stores space. I mean, it occupies space, right? It's not like an MV. It's not like an MV where you don't occupy space. It occupies space, right? Use only most frequently used and most frequently restricted columns, right? Limit columns in MVs to as less as possible. So I'll take a stop here for today.